Hello everyone. Today we will calculate the excess pressure inside a liquid drop. We know that due to the surface of the liquid, the molecules will experience an inward force due to surface tension. So to counterbalance that force due to surface tension, there is some excess pressure inside the liquid drop to keep it in equilibrium. So you can say that if this is the drop, so this force is acting inside due to the surface tension. So to counterbalance this, an excess pressure force will act outwards to keep it in equilibrium, right? So that's why this is the drop, and if we say that the radius of the drop is r, this is the change in radius to counterbalance that and to keep the drop in equilibrium, then the work will be done by the surface tension force trying to contract it. Equal work will be done by the excess pressure force to counterbalance it and to keep it in equilibrium. So you can say that work done by surface tension is equal to work done by force due to pressure difference, or you can say the excess pressure inside the drop. And here this work is done by the surface tension, which is trying to contract the drop, right? So this is actually, this work done by pressure is actually trying to stop this contraction. Right? So that's why these works must be equal. So we know the formula for surface tension. Surface tension is work done per unit area right? So this is the work done in increasing the surface area of the surface of the drop by delta A. So this is W by delta A. So from here W can be written surface tension, which I am denoting by S here, delta A. So this I am denoting by S. So S delta A is W. So this is our first expression, where we can write that this is equal to surface tension into final area minus initial area. What will be the final area of this drop? This will be 4 pi r plus dr whole square minus initial area will be 4 pi r square, because 4 pi r square is the area of the sphere, So we can solve it. This comes out to be as outside, and this will be 4 pi. This will be a square plus b square plus 2a into b. A square plus b square plus 2 into a into b, right? Because a is considered as r and b is considered as dr over here, minus 4 pi r square as it is. We can solve it. Inside this will be 4 pi r square plus 4 pi dr square plus 4 pi into 2r is 8 pi r into dr minus 4 pi r square. This dr will be very small, so we can neglect the square of this small term. Like if you have 0.1 somewhere, square of 0.1 will be 0.01. So that's why we can neglect this quantity. Dr square will be very small. So we can write that neglect this as dr square is very small. Then this and this will be cancelled. What will be left here? Multiplied by S, where S is the surface tension and this is the change in area, right? Now we can calculate, we can mark this as our equation, this as equation 1, this as equation 2, and we can write the work done due to pressure, excess pressure, as excess pressure, or you can say pressure difference. And this pressure difference, we know that the pressure inside is more because pressure on concave side is more. So I can write pressure inside minus pressure outside the drop. So this work can be written as, we know that pressure is equal to force upon area, excess pressure, this is also excess pressure. We know that work due to this excess pressure will be force into displacement, and how much is the displacement here? dr. So we can mention that here displacement is dr. Right? So F into dr, this is our equation 3 and this is our equation 4. So from 3 in 4, W is equal to, F is what? Excess pressure into area into dr. Which area we are talking about? Because this excess pressure is shifting this way, outside. So initial area. So W is equal to excess pressure into area is 4 pi r square into dr, and this work must be equal to the work done by surface tension. So I am marking this as equation 5. From 2 and 5 in equation 1. So work done by surface tension is how much? S into 8 pi r dr is equal to, fifth one is P excess into 4 pi r square dr. Let's check what can be cancelled from here. Dr can be cancelled and pi can be cancelled. Single r can be cancelled, and this 4 will cut it 2 times. So this will be, so you can neatly write it, 8 is cancelled. So S into 2 upon R is equal to P excess, or P excess is equal to P inside minus P outside is equal to 2S upon R. But for a soap bubble, we know that it has two surface areas. If we talk about a soap bubble, soap bubble has how many liquid air interface? If we talk about this is liquid, this is air, and we talk about this is liquid, this is air. So how many liquid air interfaces are there? Two interface. So it has excess pressure is equal to 2 times of 2S upon R, that means 4S upon R, as it has two liquid air interface. Then we have case 2. Air bubble in water. Here also excess pressure will be 2S upon R, because it also has one liquid air interface. This is liquid, this is air. And if we are talking about this water drop, then this is water drop and this is air. This is liquid, this is air. So one liquid air interface. So this is all about excess pressure. If I want to find the inside pressure will be 2S upon R plus outside pressure. So this is all about excess of pressure in a liquid drop, or you can say excess pressure in a liquid drop. So that's all for now. Have a nice day.